And we'll get started in just about a minute while everyone logs on. Hello, I'm Matt Thurber, Editor-in-Chief at AIN Publications. And thank you very much for joining us today. We're going to discuss an important topic in this webinar, the effect of new 5G telecommunications networks on avionics installed in many aircraft. And these are avionics that are critical to flight safety. We're also going to discuss how NextGen infrastructure is going to help with this situation. And joining us today to help us with this exploration, we have Nathan Hernandez, Business Development Manager at Southeast Aerospace, Dr. David Redman, Director, Aerospace Vehicle Systems Institute, and also an RTCA committee member, and Ashley Ring, Vice President, Sales and Marketing at FreeFlight Systems. And FreeFlight Systems is also the sponsor of today's webinar. So just a little housekeeping, today's webinar will be recorded, and we're going to send all participants a replay copy of the recording tomorrow. I'm sure everyone will have plenty of questions for the panelists, and we're going to get to those. If you have a question, just type the question in the question section on your webinar panel, and we'll address them at the end of the webinar. And in addition, if you would be so kind, there's a survey at the end of the webinar. Shouldn't take too long to fill out. So just to get started, we're going to start with a poll question and check your knowledge on 5G technology. Why is 5G different than previous generation networks? And we're starting to get some answers. The majority are 5G uses different frequencies, and now 5G has more bandwidth is taking over in front. 58, 59%, 5G has more bandwidth. 6% 5G is just faster. Now we're up to 61% more bandwidth. I think that's going to be the predominant answer. So, Ashley, any surprises here with this poll? Is that pretty much what you expect?
Yeah, that's a pretty good answer. Yes, yeah, that's a pretty good turnout too.
Great. And Dr. Redman, what do you think about the answers to the poll question? Is that about what you expected?
Yeah, that is what I would expect. Certainly that's what has been present in all the marketing that we've gotten from the telecommunications companies. So I would expect to see something like this, yeah.
Great, thank you very much. So let's start with you, Dr. Redman. What is 5G basically, and why is everyone talking about it?
Well, 5G is it's a telecommunications standard that's being developed by a consortium of wireless telephone companies under the 3GPP partnership, which defines the standards as they've done for the previous generations, 1G through 4G. And really, it's a collection of standards that define the basic technologies that are used to implement 5G. And different companies will implement them differently. As long as they're all compliant with the basic standards, then they can work all together as a large network. However, different companies will perhaps use different frequencies that they're licensed to use and do some of the specific implementation within that standard differently than their competitors. But when we hear about 5G, it's largely a marketing term at this point, because it's a collection of technologies. So there's not one thing you can point to and say this is 5G. And as the poll indicated, there are a number of benefits that come with it. And these are all implemented underneath that standard. And the standard's flexible enough that it can accommodate all these different kinds of usage. Now, what we're concerned with in aerospace is that it's bringing new technology or new frequencies to bear than what has been used in the previous generations. And these start to impinge on the frequencies that are used within aerospace.
So just to clarify, it's a standard. 5G is a standard, but a bunch of different companies are going to offer 5G networks. But really, are we? We hear from companies now, providers saying we have 5G, but do they really have 5G now, or is it something that's coming?
Yeah, they can obviously say they have 5G now. You can implement 5G over the existing frequencies that are used by 4G, but not all aspects of 5G are available, and certainly not 5G in the frequency bands that we're concerned with, because those have yet to be licensed. So yeah, you can say there's 5G, and it is present in many parts of the world, but it's an implementation of just part of the standard at this point.
Okay. And then we also have heard about a company called Legato that is going to possibly use some frequencies that are of concern. Is Legato the same thing as 5G? Is that what they're proposing to do here?
Yeah, Legato is purporting to be a 5G solution, and as long as they are compliant with the standards, the 3GPP standards, they can claim to be so. But again, it's a broad enough term that they can fit just a subset of the standard in their planned application and still call it 5G. So, yeah.
Okay, so let's talk about some of the concerns with 5G interference. And Ashley, can you start with that? Then maybe Dr. Redman can finish up.
Sure. So as Dr. Redman said, right, this 5G technology is a newer technology, and because it is being deployed, globally, there are some different considerations when you look at the frequencies and the bandwidth that is available. So a lot of the technologies in aerospace have been around for decades and for a very long time. And so a lot of the technical standard orders and specific things that were designed for were not considered that the bandwidth would be this consumed at this point when the equipment was still being operated. So from an aerospace perspective, that's probably one of the biggest considerations, is looking at what is available as bandwidth in the market, and then looking at what sort of spectrum that the aviation community needs to have to operate. And so outside of, the traditional radar altimeters and GPSs and ELTs and things like that, looking at the next coming technologies like Wi-Fi and Iridium services and things like that, that also need a wide bandwidth. So those are some considerations to look at.
So Dr. Redman, more specifically, the part of the problem is that, as Ashley mentioned, the technical standard orders, or TSOs, are pretty old for the avionics technology and haven't been updated in a while.
Well, we have to be specific. The TSOs governing radio altimeters specifically are quite dated. It's true. But the TSOs are based on designs, and so you get a design approved by the FAA under the TSO, And so as long as these designs are consistent and there's no major changes, then a altimeter that's been approved under a TSO is fit to operate in any aircraft, any certified aircraft, until there's a major design change that might invalidate that. And there's the same with FCC licensing that goes along with those. So the fact that the documents are older it doesn't obviate the need for continued safe operation despite changes in the frequency spectrum nearby. The radio altimeters and the GPS were designed to operate in the RF environment that was present at the time they were being developed. And these changes to the frequency spectrum is what is causing the issue. And yeah, we have to accommodate that. And we're working in the standards committees and with the regulators to bring things up to date to the more crowded RF spectrum that we have these days. But it takes time in aviation, as we all know, because we have such a high premium on safety. So
Exactly. Very good. So Nathan, can we talk about the importance of radar altimeters? Your company installs these, and what are some of the safety considerations? And I mean, why are radar altimeters important for your customers?
it's on you.
Yeah.
Go ahead, Nathan.
Gotta love forgetting that mute button. No, I mean, one of the biggest things with your radar systems, your radio altimeters, is really going to come down to the aircraft's operation. You know, you typically will not see a radio alt system in a lot of your single engine piston aircraft, even some of your smaller twins. You're really getting into more of your jet aircraft, helicopters, especially military aircraft, because of the fact they're operating at lower altitudes. You know, a radar system is a standard pulse system that's, if I remember correctly, you're only reading up to 2,500 feet. So when you're in a small helicopter, especially law enforcement, military, you know, you're going to need to be able to make sure that you're getting an accurate reading of what your terrain is, how high you are off the ground. And that's one of the biggest reasons why that system is implemented on most military aircraft, especially.
And Ashley, are there a lot of radar altimeter systems out there? I mean, obviously FreeFlight makes them, but how
Yes.
prevalent are they?
Yes. So as Nathan mentioned, right, they are installed in, there was a mandate for radar altimeters back in 2017 for all HEMS mandate operators to have radar altimeter on board. So that included, you know, not only emergency vehicles, but anyone who was operating a Part 135 certificate with helicopters, but also in business jets. And as you move up into commuter and airline transport, you're now using not only a radar altimeter for terrain awareness, you're using it for auto land and navigation, and it's combined with an FMS system to give specific navigation support. So it is a very important piece of equipment on board to provide all sorts of information for different reasons on the aircraft.
Yeah, it's fair to classify it as safety critical.
Yes, there is a, yes, safety critical.
Excellent. So, Dr. Redman, can you get into more detail on the testing that the Aerospace Vehicle Systems Institute has done on 5G interference and how it affects radar altimeter systems and other
Sure.
systems?
Yeah, so we started this investigation looking at wireless avionics, or WAKE, which was authorized under the ITU to occupy the same band as the rad-alt band. Although the allocation was made, there are no systems deployed yet to date. We're still working on the requirements for that. But we started to look at what would the effects be on radar altimeter performance if you had in-band interference. Well, at the same time, there was all this movement in the ITU to get new frequencies to implement 5G, including frequencies that were near the radio altimeter band. So that was generated some concern in the aviation industry as to whether that would create interference to radio altimeters. So we started a project to look specifically at out-of-band interference effects on radio altimeter performance. And we started to look at the immediate threat from the proposed auction of spectrum in the C-band from the FCC between 3700 and 3980 megahertz. And we did some preliminary studies, filed some reports with the FCC. We were frankly anticipating that we wouldn't see any issue. But we needed to verify that would be the case and base it on evidence and not just conjecture. And so we were quite surprised when we saw some effects of interference using a very simple representation of the 5G signaling, orthogonal frequency division multiplexing signals, as they're called, or OFDM. And we used a very simple representation, and we saw effects from 100 megahertz wide signals located up to 200 to 300 megahertz away from the 4200 megahertz band edge, which was, as the graphic shows, the frequency rejection in the altimeters rolls off pretty slowly and extends into that band. And so we saw some effects, and then we had to dig into that more deeply. So we started to model the signals more accurately on 5G signals, which we got from the 3GPP standards, and surveyed 9 commercial radio altimeters to understand at what point, at what interference power level do they start to break. And we documented those thresholds and provided that to RTCA. RTCA then in turn did a study analyzing the potential interference levels from the intended deployed footprint of 5G, both base stations and handsets, to see if radio altimeters would be exposed to levels of interference that were above the thresholds that APSI measured. And that's documented in the RTCA MSG report that was put together by a task force under RTCA Special Committee 239 that you had referenced there. And that report was filed with the FCC and demonstrates that in many instances across all types of aircraft and many different operational scenarios, both fixed-wing, helicopter, commercial, business, small aircraft, they will all experience some interference based on our calculations. So we proposed that those could be addressed through mitigations and have suggested that there are some potential mitigations that can be implemented when 5G rolls out and to keep aircraft safe. And we're still working through that process right now.
Great, thank you very much. So Ashley, for manufacturers of radar altimeters, what are they thinking of as far as mitigating these interference issues?
Sure. So FreeFlight recently announced our 4th generation radar altimeter series, the Turing series, and this will be out in the fall. But we are looking at both software and hardware filtering mitigations in there, with additional testing to support any sort of frequency things that may come across. Of course, some of this is in-house, so I can't really share the details of it, but it will have to be a combination between a software and a hardware changes in there to support those types of operations.
So obviously, this is something that other manufacturers are going to have to think about as well, right? I mean, because the interference is not going to go away, apparently.
Right. Yes. So, and like I mentioned before, radar altimeters are one of the products that are the most forefront right now, thanks to Dr. Redman's testing, but it will affect other equipment as well. So, we're looking at radar altimeters first, and then there'll be other things that we look at down the road, and I'm sure other manufacturers are looking at the same things. I think we mentioned earlier about TSO standards evolving and changing as the environment around them in which they operate change. So that should be, those are one of the things that will be changing as well.
Great. So let's go ahead and we have a second poll question, and we're going to ask the audience, what concerns do you have about 5G effects on avionics. And let's see how people answer this one. And so far, looks like the majority have heard that there's might be interference issues. And some of you haven't heard your avionics shops talking about this yet. Most are still just hearing about interference issues. Obviously, that's a big concern. Yep, that's still still tops. We do have a few respondents saying they have seen some interference issues in their aircraft. That's very interesting. Avionics prices is very low on the poll. So let's see the results. And yep, the majority have heard there may be interference issues. And Ashley, would you like to comment on this poll?
I think it's great that people are paying attention already to this. I think, there's been a lot of changes in the aerospace community and a lot of new technology, even in the past 5 years, but 10 years. And the different technologies coming out moving forward in the next 10 years are going to be different. So I think that the fact that people are paying attention to this interference concern this early in the concerning market is great. I think it's wonderful.
And Nathan, I thought it was interesting that very few people indicated they've been talking to their avionics shops about this. Are your customers saying anything about these concerns yet?
At this point, there haven't been very many questions in regards to it. The biggest thing we're seeing is, obviously anything with 5G and cell phones is all going to be a low altitude frequency band, and so, I think that's one of the reasons why the rad-out is one of the first areas that you're really looking at, because these are all ground-based antenna towers. So as you're sitting there seeing a lot of these aircraft, and there's, if we do start to see these interference issues that come forth, it's going to be a much hotter topic as the issues start to arise. But I think that's going to be the biggest question, because people are still wondering, and it's kind of like when we saw the ADS-B really start to come to fruition back in late 2000. Early 2010, as people were starting to see that, okay, we've got to do something about this, and it's a slow moving animal at this point in the game.
Exactly.
There are
go
sorry,
ahead.
there are some issues with handsets on board, specifically smaller aircraft too. So in addition to the ground-based routes, which are certainly higher powered, we did observe some effects from signals representing handsets on aircraft. So we need to be a bit careful about that as well.
That's actually a good point. Nathan, I'm sure you've run into this before, where a customer has a weird interference problem, and I expect one of the first things you tell them is, look, turn off your cell phones and see if that makes it go away, right?
Oh, there's a long laundry list of things we start to go through first and foremost. Obviously, audio interference is always one of the worst things to troubleshoot in an aircraft, because there's just so many things that could cause static over the headphones, crackling in the voice. I can tell you that as an installer and as an avionics troubleshooter, the second a customer comes in with that and it's an aircraft you've never worked on, you always kind of get a little leery of how long it's going to take to hunt down that problem. But I think, when we're looking at air interference where it could be causing needle movement, in the case of a rad-out where, you're possibly sitting at 1,000 feet and your needle starts to quiver back and forth and you're seeing a different reading than you actually are at. If God forbid, you're starting to see indication changes on your EFA system, I think those are the interferences that we really need to be concerned at, because at a lower altitude, that's where your pilot only has moments to make adjustments. And if you're starting to see needle movements in an IFR condition, that's the last thing you need.
Exactly. And presumably it could also affect whatever audio output you're getting from the radar altimeter too, right?
In theory, the rad-out's audio is a tone. You've reached your decision height. She's not doing a whole lot of talking.
Yeah. So, Nathan, can you tell us some of the considerations that, as an installer, need to be considered for a typical radar altimeter installation?
I mean, in these scenarios, I mean, the most of them are going to be a standard R&R, a standard remove and replace, where you're going to be removing an older radio altimeter system to install something newer. So, I mean, your considerations are a lot of times very simple. I mean, your helicopters, obviously, it's always going to be a matter of real estate for your antenna locations. Each OEM is very specific on the distance between your two antennas, side by side, forward and aft, your grounding planes, coax length. So there's a number of considerations that each manufacturer is going to specify in their installation instructions. The nice thing is when you're doing, a standard R&R, when you're removing an existing system for a newer one, a lot of that work is somewhat already been performed, because in a lot of cases, you're already going to have an antenna location that you can reuse, an RT location you can reuse, indicator, et cetera. It's going to be the aircraft that don't have one that need a new one. That's when you're going to have to be looking at, again, with a helicopter, what sort of tail boom SDC is there to put the antenna on? If you're dealing with a fixed wing aircraft, are you able to get the spacing? Those things like that.
And there's sometimes a case for dual installations, right? Are there special considerations for that, like antenna distance and things like that?
There's always a lot of special consideration when you're getting into a rad out, or even when you get into some scenarios where there's three, and that's typically going to be in your airline systems. There's a lot of communication back and forth actually between the rad outs themselves, making sure that they're not interfering with one another.
Interesting. So, Dr. Redman, if it's going to take so long for the TSO to be updated, what are some of the possible mitigations that are being considered right now, like by the RTCA committee?
So the RTCA committee was put together specifically to look at this issue of kind of the staleness of the existing minimum operational performance standard, or MOPS, with regard to all the changes that have been going on. And so the intent was to update that to make us compliant with modern spectrum usage. And we started that process last year when the committee was formed. But it takes a while to work through this. We will update the MOPS that form the basis of the TSO, and are trying to accomplish that within the next 2 years, I think, to be published by the end of 2022. At that point, it's up to the regulators to pick that up as acceptable means to ensure that that they issue a TSO that will result in equipment that meets its performance specifications in all environments. And so, yeah, it takes a while to roll out. And then at the end of that, we have to deploy them on actual aircraft. Once you have new designs that are produced that are compliant with the new regulations, they have to be built and deployed out onto the existing aircraft. So there's a long logistics tail there that even if we turn the new standard over next week, would come to bear certainly exceeds the time frame that they want to implement 5G. So things like what FreeFlight is doing to update their designs, examine their designs, and make sure that they're doing what they can with filtering to address the immediate concern is certainly welcome. I think that will help mitigate some of the issues we identified in the RTCA report. But new equipment will have to be built that is compliant with new standards. And so what we're doing now is addressing the immediate concerns that were identified, but the full set of performance specifications will only be implemented on future models of altimeters.
So just to clarify, is the RTCA committee going to inform the work that's being done by Euro CAE on the minimum operational performance standards and ICAO on the standards and recommended practices to get those updated?
Yeah, so the SC239 is working jointly with the EuroK Working Group 114. They work in a completely coordinated. We have plenary meetings every meeting, so we're working in lockstep, and there's really little distinguishing the two groups. So when the standards come out, it will be put out as both a DO document and an ED document. The TSO and ETSOs that are produced will reference whatever consensus document there is, but they'll be the same essentially. So yeah, that effort is coordinated, completely coordinated, and we'll work as fast as we can to get it up to you. So.
And I assume that you're also working together with other organizations on this, like Aerospace Industries Association, Alpha, Gamma. In fact, there's a 5G task force, right?
Yeah, there's a 5G task force. We're still representing our concerns into the FCC and trying to encourage FCC, FAA, NTIA, all DoD to work together to make sure that we resolve the outstanding questions on potential interference. You mentioned ICAO. We're working with the Frequency Spectrum Management Panel, or FSMP, at ICAO to implement SARPs. SARPs will work in concert with the MOPS documents that are produced by EuroK and RTCA to govern the frequency-dependent rejection mask, or the spectral characteristics of the input to the radio altimeter globally. So that will be all coordinated globally, because 5G is being implemented globally in different frequency bands. So we have to have a unified, consistent picture of the environment in which altimeters need to operate, because aircraft work all over the world. So yeah, this has all been coordinated. We'd like to get some more coordination with the wireless industry, and that's what we're working towards now, to make sure that we have a consensus picture of what needs to be done in the near term and over the long term.
Thank you. So Ashley, as a manufacturer of these systems, how do you prepare a new product that's coming out now for a future technical standard? Is it going to be sort of ready to meet that standard when it comes out?
Yes, that is the goal, is for us to work very closely with the 5G task force and people like David Redman, so that we understand the new requirements that are coming down, so that we can be leaders in the manufacturing space to support that. FreeFlight has a long history of RF work. As I mentioned before, this is the third or fourth generation radar altimeter that we have developed internally and built from the ground up, and all of our engineers are working very diligently on this. But just like I think Nathan used the ADS-B example earlier, right? So when ADS-B first came out in 2010 and that was released, there's the TSOs attached to it, of course, but then specific things were amended to match the environment, and things were considered after the advisory circular was put out. So there's always different things that will happen on both the administration side and the manufacturing side to meet those requirements as they evolve.
Great. So Nathan, looking at it from an installation standpoint, for an aircraft that doesn't have a supplemental type certificate, how hard is it to develop an STC for a new installation?
Well, it's going to depend upon the aircraft. I mean, the job aid is going to give the installer directions on whether or not an STC is going to be required.
Okay.
I mean, with a radio altimeter system, you're going to be able to use engineering data to perform that installation. Will most likely, unless an FAA change takes place, you'll most likely not be required to obtain an STC to install a radio altimeter system in an aircraft. And I think one of the benefits to the radar system as a whole is, and especially with the way the aerospace industry has changed with a lot of their use, is the systems today are more software driven. So even though, sadly, like Dr. Redman shared, we're going to be roughly 2 years out before we possibly see a new TSO standard for the 50+ old standard that we currently are using. Companies like FreeFlight and others out there, are going to be able to adapt their software, hopefully, to meet the TSO standard, as long as there are major hardware issues.
Great. So Nathan, if you're installing one of the new FreeFlight 4th generation radar altimeters and it's replacing an existing system, is that a fairly easy process?
It really is. Your system is pretty much very self-contained when you're talking about your smaller aircraft. So if you're getting into some of your business jets, smaller business jets, light helicopters, it's a strictly standalone system interfaced with itself. The antennas, going to the RT indicator, so on and so forth. The biggest hurdles that could come into play is when you're getting into your larger category aircraft, where you're interfaced with your TCAS-2 system, larger helicopters, or your interface with your HTOLs. That's where some of the problems could come into play in regards to how well the older systems are receiving the data from the newer one. And that'll be some of the things the hurdles that'll come into play at that time.
Great. So, Dr. Redman, there is a sort of a different approach that France has taken with regards to these interference problems. They've got some new rules for airports on how to deal with this.
Yes. So in response to the risk that was identified in the FCC report, France took immediate action to exclude towers from 5G towers from the vicinity of a runway. Because one of the scenarios we studied in the report was what we call a worst case scenario, because you're dealing with not only 5G interference, but interference from aircraft ground that also have radio altimeters. So a fairly noisy environment at a critical point. And so until they collect more information, they wanted to take immediate action to ensure that the radio altimeters continue to operate safely. So they made some things. And as we talked about, it's a matter of timing. So they're in place until evidence that they're no longer needed. At this point, they're not allowing cell towers in the proximity of the runway.
So that actually brings up a good point. The 5G networks are going to rely on cell phone towers to receive and broadcast all this RF. Are there going to have to be standards, do you think, for how close they can be to airports while airplanes are more susceptible to interference being closer to the ground?
Yeah, I mean, that's one of the strengths of 5G is that there's a lot of flexibility on how you can deploy different topologies, microcells, different topologies that could accommodate airports. And so, at least for the time being, with the current equipment, that's one of the options that we suggest is either limiting power or the operation of the antennas, because the antennas can scan an angle, so that we're limiting the amount of RF power from 5G sources that can reach and that will be necessary until we get equipment out there that can operate correctly in those environments.
Okay, and I just want to mention to the audience that Dr. Redman has said he's welcomed any reports of interference, and he's offered that people can email him at dredman@tamu.edu to report any interference situations to him. Thank you for that. So, Ashley, as far as the new generation radar altimeters, if a customer already has a FreeFlight radar altimeter, is there some kind of upgrade program, or how's that being handled?
So yes, there's a trade-in program, and we, of course, are taking a case-by-case basis upgrades for existing radar altimeters into the new terrain series, and in new installs as well. So for not only replacements of, but for other manufacturer products.
Great, thank you. And thank you very much. Now we're going to go through some of the questions from our audience. And I know this, we've talked about this a little bit, Dr. Redman, but can we just reiterate where 5G is at right now in terms of adoption, and how soon we might see more effects on the aviation industry?
Yes, the status in the US is, and I'm getting some feedback, so I'm not sure if somebody's status in the US is that the auction was completed. It started in December. It was completed early this year. So the spectrum from 3.7 to 3.9 gigahertz in the US is already allocated. It will be licensed later this year. So once operators have a license, they can start networks. So we're anticipating by early next year, working instances of 5G, and we've got a very short clock to make sure that we address our concerns before that happens. Certainly within the time frame of the completion of the new.
Thank you. And Nathan and Ashley, this question's for you. The question is, will protected radar altimeters require a full replacement of existing hardware or an upgrade to existing equipment? And how will that affect the cost?
So I can only really speak from a FreeFlight perspective, but there will be an equipment upgrade required, hardware required, and then for the existing equipment. But I think Nathan can maybe speak for some of the other manufacturers and what they might do. There might be software upgrades or other things available.
Did you, Matt? Did you say protect? Did you say protected?
Yeah. I think the questioner is asking for having a system that is protected.
Oh, I mean, realistically, for any of the operators, I mean, if they're dealing with a newer radar system, something within the last 10 years, their upgrade path is probably going to be somewhat easy. If they're dealing with a much older radar system, the cost is probably going to still be about the same as something brand new.
Okay. And are you hearing yet from your customers, like commercial airlines, for example, on their oh, I'm sorry, this question is actually about airborne connectivity. Yeah, it's not really applicable, I think, to this conversation, because, well, actually, maybe it's a good question. If airborne connectivity systems are using 5G technology, does that add to the interference problem, or is that a completely separate problem?
Well, I think Dr. Redman is going to be able to expand on that, but I think that is one of the big questions, because you're already starting to see Are you getting that interference? No.
Yeah. I'm muting while I'm not speaking, so maybe that's the best thing.
I think that's just going to be a question to see moving forward as this continues to, I guess, mature.
Yeah, and it depends on, again, we got to be careful how we use the term 5G. And it depends on what frequency band it is. It depends on the application and the usage scenario, what kind of threat it might pose to existing avionics systems. So we have to look at it on a case-by-case basis. Certainly connectivity is a driver for the future, and needs to be safely implemented. Part of the issue here is that with this specific 5G telecommunications interference issue, we don't have control over half the problem. 5G networks, terrestrial networks will be deployed according to the wireless industry's requirements, and we have to live in them. When it comes to onboard communications, we certify an aircraft, so we have control over the systems that go on board that. So we have a much better handle on how to resolve any potential interference issues when we're integrating things onto an aircraft.
So, Dr. Redman, one of the questions is there a map of 5G towers, or will there be one, so you can look and see if there's any near your airport at all?
Yeah, there is. There's cell phone towers have to be registered. So there is a database of cell phone towers. That's part of the study that we're doing today, right now, is taking that database of cell towers that would be equipped with 5G advanced antenna systems and fixed sectoral antenna systems, and with and their proximity to airports that support ILS and other types of automated landing systems, where the radio altimeters are an essential part of that system, to understand what the threat could be, how pervasive or dispersed that threat could be within the US. And also for aircraft that fly outside the US, there are other countries, UK, Japan, all over Europe, that are implementing in slightly different frequency bands. The study that RTCA did was specifically for 3.7 to 3.18 gigahertz. But we have to understand, and that's part of the RTCA committee's work right now, what risk other implementations might pose. But yeah, for connectivity, I think it's a more tractable problem for onboard systems.
Thank you. And this is for Ashley and Nathan. What are the typical symptoms when radar altimeter interference happens? What does that look like?
So we normally see it if there's an eradication on the decision height. So if you definitely know where you are and it's showing something different, or you get an error code, or display an error code, or that sort of jumping around that Nathan had mentioned before, those are key indications that there's something that's going on that needs to be looked at. I don't know if there's anything else, Nathan, that you have typically seen, but those are the telltale signs for us.
Yeah, erratic needle movement. That's pretty much your common sign if you're starting to have issues there.
Right. And Nathan, here's a question for you. Do these new 5G immune radar altimeter systems reuse the existing antennas, or do you have to install new antennas?
We'll find out. I mean, odds are, even if it's a different antenna, it'll be reutilizing the same footprint, so that there'll be no structural changes. But I mean, whether or not it's going to be the exact same antenna. I mean, actually, do you know if you guys are going to be using the exact same antenna as the 4500?
Yes. So for the terrain series, you can use the existing antennas for not only our 4500, but if there's a Honeywell one or a Collins one on board to replace it, those antennas can be used as well. So yes, you can use the same antennas.
And Dr. Redman, what is the FAA's perspective on this? I don't think we've really heard from them very much talking about this issue. I assume they participate in the committees and everything.
Yeah. They're driving the issue. The FAA participated in the AVSI project, so from the earliest days, they've been aware of the experiments we've been doing. They participate in the RTCA committee work and are one of the leaders in the FSMP at ICAO. So they're engaged on all fronts. But their ability to address spectrum regulation issues is limited due to the allocation of responsibility within the government. That's the FCC's domain. FAA is responsible for aviation safety. And so by identifying potential interference as a safety issue, FAA can work it from that side and try to understand and work with the FCC to determine appropriate action to keep things safe. But they've been engaged on all fronts from day one. So, yeah.
Excellent. Well, that's about it for all our questions. We really appreciate everyone's participation and also thank FreeFlight Systems for sponsoring today's event. And just a reminder, the webinar has been recorded and will be shared with everyone tomorrow. And thank you very much for sending all your questions and for participating. I've certainly learned a lot and hope you did too. Take care and have a great day. Thank you, Ashley.
Thank you. Okay, bye.
Bye-bye.